Hello, beautiful people. This is part 2 of your Integrated Math 1 Unit 6 review for your test that's coming up. Part 1, we covered questions number 1 through 6. We're going to start with number 7 here. Disclaimer, if I make a mistake, I am human. Just let me know where the mistake occurred so that way we both can learn from it. Also, we are on campus, so if there is a loud bell or the intercom goes off, just let me know. Not let me know, because I will know when the intercom goes off. But I do apologize in advance for any loud noises. And then in video part 1, we talked about the growth rate, and I said in part 2 that I'd come back to it. So I do want to come back to question number 6b when it's asking for the growth rate, and wanted to clarify some things. So when you're looking at your formula, in this case, let me rewrite it so you can see it better. We have f of x is equal to 110 times 1.25 to the x power. You're looking at, think of it as a geometric sequence formula. This would be your common ratio, kind of. So this right here, your growth rate, the formula is 1 plus r is equal to 1.25, and whatever that is. So in order to find out what your growth rate is, you're going to actually solve for r, so I'm going to subtract 1. So r is 0.25 or 25%, okay? So just set up your equation and then solve for your growth rate. The easiest way, if you have something that's 1 point something, it's easier to find out what your growth rate is without using the formula, but if you don't know what it is off the top of your head, then use the formula. All right, let's move on to number 7. Number 7. Right, for each sequence below, determine if the sequence is linear, which is arithmetic, or exponential, which is geometric, or neither. So we're identifying the pattern. So what's the pattern? What happens? From 225 to 25, from 25 to 5, from 5 to 1. Let's see what our pattern is. Let's see what our pattern is. So I'm thinking it's going to be division, which is multiplying by a fraction. So I'm taking my I'm taking my right, dividing it by my left, taking my right, dividing by my left, taking my right, dividing it by my left. And again, it has to be the same number or it doesn't work. So 25 divided by 225, and that gives me, I'm going to do that again, 25. Let's see here. I'm trying to see if this calculator that I have in front of me will. So this right here is 1/9. This is 1/5. Because 5 times 5 is 25. This would be a neither. Because these values don't match, therefore it's non-arithmetic and non-geometric. Okay, let's try this one. 2 times what is 6? And again, I'm doing times because I'm noticing that the growth is bigger. So let's see. 6 divided by -2, 16 divided by 6, and then 27 divided by 16, like that gives me a headache. So let's see. 6 divided by -2 is -3. We know that. 16 divided by 6, that is not -3. So this is a neither as well. 1 to 5, 5 to 9, 9 to 35, 35 to 36. Okay, let's see here. 5, so this is plus 4. 5, 6, 7, 8, 9. This is plus 4. And then 9 to 35, that's a big jump. So this is definitely not plus 4. So this is not plus 4. Let's see if this is geometric. So this tells me it's non-arithmetic. So let's see if it's geometric. 5 divided by 1, 9 divided by 5, 35 divided by 9. So this is 5. 9 divided by 5, I'm going to save that one because 35 divided by 9 is also definitely not 5. So it's not 5 and this does not equal 5. So it's neither. Okay, let's see. This one here, see if we can add. I'm thinking multiply because I'm thinking 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So this is in fact geometric. Okay, number 9. Determine the rate of change, R, in each geometric sequence below. If it is not geometric, say not geometric. Show all work. Okay, so we're going to say what our common ratio is, or the rate of change. So let's see, 0 to 4, 4 to 8, 8 to 12, and it has to be geometric sequence. So remember, this means multiply. If there are any that are adding or subtracting, then that means it is arithmetic, and so it is not geometric. So from 0 to 4, I get 0 plus 4. 4 to 8, that's plus 4, 8, 9, 10, 11, 12. This is plus 4. Notice how it is plus, the pattern is a plus. That means it is arithmetic. And per the directions, we have to write not geometric. Okay, let's try 6. Let's try B. 6 to 16, that's, I'm adding 10. 16 to 36, again adding 10. And again adding 10. Once again, our pattern is addition. So that means this is arithmetic. Arithmetic. So not geometric. Okay, let's try here. 8 to 24, 24 to 72. So that actually is too difficult for me, so I'm going to go back to doing my right divided by my left. So 24 divided by 8, 72 divided by 24. So 24 divided by 8 is 3. 72 divided by 24 is 3. So therefore, we are multiplying each time by 3, so that means it is geometric. Okay, for D, let's see what our pattern is. So 10 divided by negative 2, negative 50 divided by 10, 250 divided by negative 50, and see what that equals. 10 divided by negative 2 is negative 5. Negative 50 divided by 10 is negative 5. And 250 divided by 5, 250 divided by 50 is negative 5. So again, that means we are multiplying by negative 5. So it is, in fact, geometric. Okay. Number 10, solve for x, show all work. So again, this is 5 times 3x is 135. So 3 to the x power is in its own bubble. So get rid of this. Get rid of this section. So I'm going to say the opposite of 5 times is divided by. So I'm going to divide by 5. So 135 divided by 5 is 27. So 3 to the x is equal to 27. And then now we have to play a guessing game. 3 to what power is 27? So 3 times 3, that's 9, times 3, that is 27. So how many total 3's do I have? Oh, let me switch this up. How many total 3's do I have? I have 1, 2, 3. So that means 3 cubed is 27. So then what is the value of x? The value of x is 3. Let's do something similar in B. Okay, 2 times 6 to the x power. Again, get rid, this is in its own bubble, so get rid of the 2. So I'm going to divide by 2 both sides. 6 to the x is equal to 72 divided by 2. That's 36. 6 times 6 to what power is 36? We all know the 6 squared is 36 because 6 times 6 is 36, and that's 2. So x is equal to 2. Okay, flip the page over. It's graph. Graph f of x is equal to 1/3 to the x power. Okay. Oh, this cut off. I just noticed on B. It's okay. All right. So we're going to do this here. Here's my x. Here's my f of x. And again, you have to use a negative, you have to use 0, and you have to use a positive. So here's 1/3. Let's do negative 1 Let's do 0, let's do 1, and 2. So 1/3 to the negative 1 power, that means we flipped the fraction. Here it is, we flipped it. Carry the 1. And so this is 3. 1/3 to the 0th power, anything to the 0 power is 1. Then we have 1/3 to the first power, that's 1/3. And 1/3 squared, that means 1/3 times 1/3, that means 1/9. So here's our input, output, input, output, input, output, input, output. So when I have -1 as my input, my output is 3. Now I'm noticing this is 4, 8, 12. So this means this is 2, 4, 6, 8, 10, 12, 14. So be careful. So if I have 3 as my output, it's going to be somewhere here. 0 is 1, that's going to be here. 1 is 1/3, so it's going to be somewhere here. And then 2 is 1/9, and we're getting really super close. And again, connect, because we chose our domain. And again, do not cross this line. Notice how our numbers are getting smaller and smaller, but they actually do not touch 0. So make sure there's a gap. If there is no gap, it will be marked wrong. Let's try this one here. Again, -1, 0, 1, and 2. Here's your f of x. So I have 1/3 to the -1 power plus 3. I have 1/3 to the 0 power plus 3. 1/3 to the first power plus 3. 1/3 to the second power plus 3. So let's deal with the negative first here. Remember, negative just means flip the fraction. So here's my fraction flipped. Keep your exponent plus 3. So this is saying 3 plus 3. 3 plus 3 is 9. Anything to the 0 power is 1. 1 plus 3 is 4. 1/3 to the first power is 1/3. And then here's the trick. This says 3 and 1/3. So this is 1/3. This is 3 and 1/3. And then this is 1/3 times 1/3 plus 3. This is 1/9 plus 3. So this is 3 and 1/9. So again, input, output, input, output, input, output, input, output. So let's graph. -1, again, this is 2, 4, 6, 8, 10. So -1 is 9, so somewhere here-ish. 0 is 4. 1 is 3 and 1/3, so here's 4, so 3 is here, and 3 and 1/3 is somewhere here. 2 is 3 and 1/9, so it's going to be somewhere here. Again, if this is 3, we're getting super duper close to 3, but we're not actually touching 3. Here it is. So make sure there's a gap. There's a gap. All right, this is part 2. We're going to continue in part 3. Looks like we're almost done with the review. If you have any questions, please let me know. If you find a mistake, please let me know. Thank you for watching.